The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. Thanks for joining today's Test Studio webinar. This is Andy Wieland. I'll be conducting the demonstration today. All callers are muted throughout the call, so please feel free to be as loud as you'd like and ask any questions along the way in the chat or questions panel. We'll try to keep track of those, but you should be able to see my screen at this point and hear my voice. Any problems you might have, please feel free to chat or send something across on the questions panel. Today's focus is going to be around Test Studio's performance and load testing. We also have our mobile testing, which will happen at this same time slot every other week. So next week will be mobile testing in the same time slot. And then on Tuesdays, we always have our functional automation testing. Tune into those if you'd like to see the other areas of Test Studio. But today's focus will be on performance and load testing. And really where we start with performance and load testing is where we leave off with functional testing. So what I have up here on the screen is a basic functional test. This is just a simple login test at this point. And to begin with performance testing, we need to start with a functional test like this. You don't have to, but I'm going to go ahead and execute it just because I haven't run this test yet today. Just going to execute it real quick to make sure everything's working correctly. And then we'll run it as a performance test as well. So we'll just pick a browser here to execute it in. And of course, that's going to open on the wrong monitor. So real quick and easy there, it goes through the execution of the functional test. Everything's passing, so it looks like we're good to go. So to run this as a performance test, all you need to do is open up one of your functional tests here, as I have in this tab, and then click the Performance tab. If there are any performance results, if this test has been run as a performance test in the past, it'll gather and load those results for you. If it hasn't been run as a performance test before, it will prompt you to configure the performance test settings, which I'll show you here momentarily. Up here, you can always go back into the configuration, or if it's the first time you run it as a performance test, this will pop up for you. You're going to be able to specify where you'd like those results to be stored. And then here on the second page, we can configure if we'd like to do performance monitoring. Now, performance monitoring can take place from the machine that we're executing the test from, which is this machine, or particularly we might want to actually monitor performance of other machines too. That might be the database machine that's hosting the database of the application, or the application server, the host of the application itself. So we want to be able to read into those machines and understand how they're handling the situation. You'll see that the same thing applies to load testing as well. But to kind of give you a perspective of how we look at performance testing versus load testing, performance testing is really what we call the micro vantage point. It's going to give us very detailed data. It's going to be one user running through the scenario, but giving us very detailed data about every step of that particular scenario that's being executed, in this case, a login scenario. Now, if we'd like to, we can monitor those metrics and performance counters from those machines. You just click Add Computer, and any of our Test Studio licenses include a profiler. So you may have multiple machines that are involved in executing. You may have, as I mentioned, a database server or host app server, and they can be connected together in a test lab such as this. And any and all of these, including these ultimates and functional licenses over here, these include the profiler, as well as our runtime licenses. These are your execution agents. They also have the monitoring of performance capabilities. So here in the case of the runtime number 6, I'm actually not using it to generate any load or to execute tests on this application server directly. Instead, I'm only monitoring. I'm only using the profiler capability in this case. As you can see below, there are some ports involved with making sure that communication is open and available. But when it is, you basically can type in the machine name, click connect, and you should get a list of available counters that work for that particular machine. Now, this list of counters will be different depending on what that machine has. As you can see, there's some Hyper-V on this box. I can monitor some stats from that. If it's a database server, it might be like SQL or Oracle statistics, things like that that we might want to monitor. And there's some common things that we can start with too to give you some assistance here. Let me pull up a bit of our documentation. And you can get to this online user guide directly from the Help tab in Test Studio as well. But in here, we actually have an article that's really useful. It's called Profiling Your App. And this will go through how to really understand the performance metrics and monitoring the performance, and of course, the requirements involved with that. And there's some role-specific metrics here to help you as well. We call this a starting point. This is not the end-all be-all for all applications or all environments, but it is a good place to kind of start to get an idea of what you might monitor if you're monitoring the app server that's hosting the application, or the database server that's hosting the database of the application, or if you want to monitor the performance of the execution agent. And again, going back to our visual here, this is representing our app server. I don't have the database server represented here, but just imagine there'd be another one over here that might have a runtime on it as well. And then 1 through 5 runtimes are execution agents. These are all tied together with a scheduling server. So number 1 here is actually acting as the scheduling server, the storage server, as well as an execution agent, and as well a performance monitor. So these are very multi-purpose, very cheap licenses that we provide so that you can build out your lab of machines and get all the monitoring and all the automation out of it that you need to. So we tap into any of those. The profiler gives us access to the statistics, or to the performance metrics, and I'm going to go ahead and drop the link to this document into the chat window for you to take with you. And then back over into the test itself. What we're doing here is we're checking checkboxes to build a template. And as you can see, I've already got memory all checked here. There's all sorts of checkboxes within checkboxes within checkboxes. Every one of these has just a myriad of different things that you can look at and study. Again, the documentation will help you, I think, give you some guidelines as to where to start. And you may also want to work with your development team on maybe other areas that you want to monitor as well. But once you've checked the checkboxes and created the appropriate template of what you've got, I've got memory and processor and physical disk in here, server as well. So lots of different things that we can monitor. Once we've got that, that can actually be saved as a template to use in the future. As you can see up here, there is a save button. And there's also a file button to load a pre-saved template. So I have a database template and an app server template here. If we were to select those, it automatically makes all the selections for us. So it really shortcuts the process. Once we're done choosing our checkboxes and what we want to monitor and setting up our machines, we'll click Done Editing. Again, we can repeat this for multiple machines that might be involved in the test. And once we have that, we'll go ahead and click Save. So those are the configuration options for setting up your functional test to run as a performance test. Now, this particular test has been run as a performance test in the past, so there's some history to it. You can see here a trend line at the bottom giving us a view of how it's trending, as well as the individual results that were derived from the execution of this as a performance test. The overall test time as well. We see that one here is quite large compared to the others. Now, I want to point out that lots of times we'll have environments that are separated from the public, right? The QAT environments, the staging environments. And in those cases, you may not have any load on those environments. So doing a performance test gives you maybe some inadequate information. You definitely want to run performance tests in a no-load environment to get a baseline, but then also run your performance tests in a peak load environment and in an average load environment, so you get a good feeling for where that trend is and where it should be with regards to the load involved. Now, if you do have an outlier like this, you could delete that from the result data if you'd like as well. We'll go ahead and run this. We'll run this in Firefox because I only have one of those. We'll just click on Firefox here and execute that. This will now execute the same test, the one we saw before. It will look exactly the same too. It may take a little longer in this setup and in the teardown of the test, since it is turning on and opening up the ports and communicating with the machines and at the end it's capturing all of the data that's being collected and bringing it back. But as far as the execution of the test itself, it should not be affected in any way. Once it does kick off here, it should run just like normal. Now in this type of test, it's not concerned with functional, right? It will let us know if there's a step that passes or a step that fails, but it's not focused on failure here like it would be in a functional test. In a functional test, if there's a failure, we'll diagnose that failure, we'll get lots of failure details, and we'll go and triage that and fix that issue. In performance testing, it's not about failure. We're going to take the test as it is and provide as much statistical data back as possible. But if there was a failure, you could then go back to the functional version of that test and correct the failure there. So here's our result. We see everything did pass. We got green checks all the way down. But again, if it failed, it wouldn't really matter. It would just be an indicator for us to head back over and maybe troubleshoot the functional aspects of the test. But this is the data we're provided in the overview of a single run, a single execution of this test that's now looking at more of a step level. So we could see the server timing and client-side timing and the server in total time as well as size and any errors that may have occurred too. So this really gives us a first look at, out of these steps, which one is really maybe least efficient or costing us the most time. Now keep in mind, I do have a wait step in here for 2.5 seconds. So obviously that's a lot of time just sitting on the client side, and a little bit more than that. Looks like it was 2.6 total as it transitioned between steps. And that gives us that view of where things stand out. So here we're really looking at, from a performance test standpoint, we're trying to locate the bottlenecks in a particular application and in a particular scenario or user story within that application. In this case, it's logging in. Now, outside of my wait here, everything else looks pretty clean, right? We do see here on the step 5, there's lots of time spent on the client, very little on the server in that particular case, but it's a nice, pretty easy split, and these are pretty low numbers at this point. Now, if I run this in a peak load or average load environment, I might expect these to be increased, and I might expect certain issues to be exacerbated. And that's the whole idea of performance testing, is really to feel out where there may be bottlenecks, and that points to where you may be able to focus some development efforts in order to make things more efficient. Now, the real, I think, detailed information is here on the Details tab. You can get to that by clicking a step or by clicking the Details tab itself. And this is really that micro vantage point that we talk about from a performance test. So it was one user in this case going through a login process. And here we're seeing each step broken down to the method level and the order of operations. And if we float over these little nodes, some of them are super, super tiny because they're just very minute amounts of time that are spent, but it gives us the waiting, the sending, the receiving, all these different time events that occur that make up that particular method. And we can correlate that to the particular method in question over here, and really that's where we can look at to focus our attention. So this particular JavaScript event here is one that took the most amount of time. Now it's pretty small amount of time in the total of things, but again, this is something that if we'd see in a peak load environment, we might expect this to take 2.5 seconds just for this one method versus this quarter second that we're looking at here. We also see status codes that come back, and of course any errors too that might have occurred along the way too. Okay, so this is just looking inside of one step. We can click through and see step 2 here. And again, a lot of these are very small. We can change actually the scope up here to kind of increase the size of these, but we're just going to click through a few of them real quickly. And here you can kind of just get a feel for where you may be able to look at some improvements and where those bottlenecks might be occurring in those particular steps. Okay. Now, on top of this, literally, we can overlay all of those performance counters that we've enabled. So if I expand my machine list over here, here are all those perf counters. We could take a look at, let's say page writes per second or reads per second. We'll get down into processor and look at like percent processor time. and we can look at where the spikes occur, and we can see maybe how things line up, right? We'll get down here to further into, let's see, we've got server sessions forced out off or errored out, for example, might be something useful. Sessions timed out from the server. This would be if I'm monitoring the app server itself. And further on down here, there are tons and tons of these, and you can certainly turn them all on just to show you how beautiful that is. You could certainly turn them all on. It is better to be a little bit more pinpoint and precise. And of course, this is something that you can go through and pick away at and kind of see which of those particular performance counters are most important for you. But this really allows us to, again, overlay the important data and really kind of scroll through all these methods and see, what was it that led up to this spike occurring, right? And of course, we can overlay any of those performance counters from the other machines that we might have been monitoring for this as well. So we can have multiple machine performance counter graphing data over the top of this method level data and the timing and everything else. It's a great amount of information to really let you get that introspective on where you can get the most efficiency gain, or where the biggest problems are in your particular application, where the biggest bottlenecks might be in your application. So that's really performance testing in a nutshell. Now that was just the history, the overview, and the details. You can also compare these runs to each other. And here we could see two of these compared to each other. The last time it looks like I ran this was pre-Christmas. And it was, as you can see here, the B run versus the A run, which is the one that we just ran. So we can really take a look and see where the differences are side by side, step by step. And we can also see these red X's when we have some deltas that occur. Now these deltas are tiny, right? A lot of these are within an allowable threshold of time. And that can be modified up here so that it can really eliminate the noise. So we'll add a 3-second total time. We'll go with 2 seconds on the server, 1 second on the client. And I look back down and all of those red X's are now green. They're within the threshold. And we'll give it a data size variation 2. And now we've got all green check marks except for one red X down here on this step 6 login button step where it was, that's step 6. And basically the difference in size there that occurred just in today's run versus the last run. From here we can go back into that run. We can go back into step 6 specifically. We can overlay performance counters. Looks like this one also has some from another machine too in here. And we can basically look for, what was it that cost us that lag in time. You also can see we had some 304s in here, so a little bit different status on that return. Looks like the rest of those are 200s. So everything looks pretty good. So that comparison really kind of helps you evaluate, especially when you want to compare a baseline no load environment to an average load or peak load. Put those side by side and really look at how big those deltas are and if they fall outside of the threshold or not. And that's really all there is to it. So we're taking a test we've already built, a same test that we use for functional regression testing. We've run that same test now as a performance test, and we've got a lot of method level micro vantage point type of data back so that we can identify bottlenecks. Now performance tests can be run in test lists as well. When you create a test list, you'll give it a name and you'll assign it a type. The default is just the functional automated kind of test. So we'll go ahead and give this a name. And we'll grab some tests in here. We're just basically grabbing any of these tests that we want to include to build out our test list. And if we were to switch this from automated to performance, you'll see that it gives us some configure options here. Now, if this test has previously been configured, it's the same wizard we saw from the performance tab. But if this has already been configured once before, you don't have to go back through that again. You certainly can from here, but it will carry over any of the settings that you previously had. And it looks like it's trying to load some stuff for me here, so I'll give it a minute. But see here we have all of those perf counters already selected. We don't need to modify this unless we really want to change something around. So if you've previously used it as a performance test, that configure option isn't necessary unless you want to change something. If it's the first time you've run it as a performance test, you can do that from here, or you can go back to the performance tab and do that for each individual test as well. So this gives us a performance test list. Okay, and that can then be scheduled to run or run remotely across multiple machines. Of course, that opens up so many possibilities, and even running it from a CLI or a build server process that might call that performance test list as part of a build process or continuous integration process. Okay, so that's really the nutshell of performance testing. Again, not too much to it, just because we do a lot of the work in just creating a functional test, and it's that reuse that Test Studio really provides that allows you to just get even more mileage out of the same test. So the same test is telling us if it's functionally working correctly, and now where the bottlenecks are in the process. So moving on, we're going to jump into load testing. Now, load testing is a different type of test. If we were to, in our project, say add new test, we'll get the choice of the web test, the load test, and then of course WPF and manual. Again, for performance tests, it is a web test, just run from the performance tab. For a load test, it is a distinct type of test in Test Studio. But again, you do have the concept of reuse. We like to reuse things as much as we can in Test Studio because it cuts down on your maintenance time and you get more reliability and more mileage out of your tests as well. So from a load testing perspective, let me get back here to the design tab. The load test has a number of different components to it and configuration options to it as well. But primarily what we want to do is capture traffic that's generated by certain user scenarios. They're also called user profiles, and essentially build together a conglomerate of what the typical traffic would look like. So let's take, for instance, a Monday morning when everybody's logging on at the same time. We may have a system that just struggles a bit with that initial Monday morning burst of everybody logging on, for instance. That might be one scenario, and then there may be a small other scenarios where people are updating records or running reports, things like that. And you really want to just have a combination of traffic of different scenarios being conducted by different users, just like you would, if you think about a shopping cart application like an Amazon. You've got some people that are just browsing, some people that are actually logging into their account. You've got some people may be doing returns and RMA requests. You've got others that might be actually checking out and buying things actively. So those are the different scenarios we would want to represent in that type of application. And hopefully those scenarios are already represented in your functional web tests. If they are, you can simply capture the traffic. This is the little capture button here. You can capture the traffic from your existing web test. So again, that reuse, really just giving you more mileage again from your test. So let me go ahead and do a quick one here. We'll just do this language test. I'll pick a browser here, and it's going to now execute that. But this part does look just like we saw it previously, just like we see it in the functional test, just like we saw it in the performance test. However, once it's done with this, it will bring back the traffic for us. Now it looks like the site may have changed since this test was last run. So it might give us partial result there, it might have a failure in it. Again, this type of test is not focused on failure, so if there's an issue, it will finish out what it can from what is captured. But it's not really going to be focused on fixing the failure. For that, I'd need to go back to my functional test to do that. But here in a moment, we should get some data back, hopefully at least a little bit from that test before it errored out. we'll try that with a different test as well. Bear with me here. It looks like it may have been stuck a little bit from our GoToMeeting. We'll try to get that screen reshared here momentarily. Oh, and one thing I needed to do is actually I'm going to make an adjustment to my scheduling server. You, of course, can have that environment I showed previously where you've got multiple machines connected to each other. I actually have my machines sometimes occupied. So I'm actually going to just connect this from a local load test. I don't want to kill our session by having a load testing running. And keep in mind that these load tests can really do some damage. So you definitely want to be careful. I always like to tell people, don't forget, if you've scheduled a load test, don't forget you've scheduled a load test. But we've set that to local now, so that should be just running locally and shouldn't affect our GoToWebinar. Okay. So back into this design area, and we'll try a test that hopefully succeeds this time. We'll do capture from existing web test, and let's see, we'll do a super simple login here, and we'll have it go execute that. Again, the execution portion should look much the same as what we are used to with functional test. And now we see the traffic that's been captured, and the first thing that comes back are the dynamic targets. Now, dynamic targets are the session IDs that were detected by Test Studio. Now, keep in mind, Test Studio doesn't specifically target all session IDs. There are some out there that are more advanced. There are some that certainly if you don't see them in your list here, you can contact us. We're always trying to expand our support for different session ID types and things like that. So definitely feel free to, if you don't see it, that doesn't mean we can't do it. Just let us know what's missing if something is missing, and we can certainly try to get it prioritized. But ideally here, what we're seeing are the session IDs. In this case, there's an authentication token and a commit that were generated as the user went through the process. And the concept of this is that we want to be able to make these dynamic. We want them typically to be dynamic because that's how they usually work. When each of the users go to the page, they should get a unique authentication token and session ID that help to shake hands with the application, that let the application know throughout the process who they are and that they're allowed to be there. Now, when we capture the load test scenario and get the traffic like this, it's captured the value of these session IDs at the point of execution. So over here, this value, this particular key here, is what was captured at the point of execution. And this might not be something that is valid for other users or might expire. What we typically want to do is we want to enable these. This list really gives us the option to view them and turn them on and off, making them dynamic or making them just disabled in the test itself. So typically we're going to just check the checkbox to make them all dynamic, because that's generally how they work in real life. And we'll click done. You can get back into the dynamic targets up here. I'll show you another scenario where there's a ton of dynamic targets, and sometimes there certainly can be some noise that you don't necessarily need in your load test. But this is a pretty clean test here. You can see all the steps of going to the page. We also do have think time, and actually let me go ahead and click on the first one here where you can see the request as well as the response over here. There's a set cookie step here as well. And step by step, we can see all of the different data points that were captured from that. And as I mentioned, there's think time. Now, think time is something that's generated to give you variability. This means we put time into the test to make it so that each of the virtual users, that when you execute this with, let's say, 100 users or 1,000 users, we want to have a little bit of variation that's more like the real world. And think time helps you do that. So robotically, every virtual user will go through these first 4 steps, and then when they get to think time, they'll sit and wait. And they'll sit and wait for a duration of 10 seconds plus or minus 3 in this case. This is something I can completely control and customize. I can also get rid of think time, and I can also add additional think time into the test. The idea here is that now each virtual user will vary a little bit, and that will be a little bit more similar to what the real world is like. Okay, not everybody operates like a robot, so we make our tests so they don't act like robots, they act more like people. So you can add that think time, you can modify that think time, and so forth. Here's our post operation. And in the post operation, this is where, in fact, if we go back and look at our dynamic targets, you can see where the dynamic targets are generated and captured from step 0 as soon as we hit that page, and where they're used, in this case, step 7, and that's the post operation. And here you can see the actual authentication token again, and it's set to from step 0. The reason it's set to from step 0 is because we've turned it on in the dynamic targets section already. But here I can change that if I needed to. It'd basically be undoing what I just did, but the idea is that it exists in both areas. So I could actually go back to the value that was captured at runtime, or I could go to the dynamic value, which is captured for each virtual user separately at their execution time. Or I could even data drive it. So there's actually a data source on this test already, and that's why we see these other columns of data here. This is also how you can take a scenario and data drive it. So here's the username and password that were passed by the functional test that we just captured. And if we have a set of data, maybe from a spreadsheet or a database that we want to use, we could actually set that up in the performance or in the load test here so that each virtual user could log in as potentially different real user with a different username and different password from each other. And so that way we've got all these different users logging in, or slightly different timing involved, so it's a little bit more real world, and we can even have them logging in with different sets of credentials that are coming from a data source. Okay, now that data source is something that you can bring in at the project level. I can show you where that is as well. But once it's attached to the load test, you'll see there's a little data icon here indicating there is data on that load test. There's a functional test down here that has data on it too. Now, keep in mind that if I captured this simple login test down here, which is data driven, that's different. That's a functional test that's data driven. So that means these 14 steps would be captured multiple times and be repeated in this list. And that's typically not what we want, because that means when we execute the load test, each virtual user would be attempting to log in more than once per user. Usually we want them to log in one per user. So that means you typically want to capture one single iteration, just like we did, of that login process, and then add data to it in the load test. So this is different than data driving a functional test, and typically we're going to capture just one iteration, add the data in, and here we can just choose our username and our password columns, and we now have a data-driven scenario within our load test. All right, so next we'll go ahead and jump out of this. Oh, I should mention too, there's some filtering that you can do, some cookies you can add in as well, and even some simple find replace. So maybe we migrate this to another server, we can do a find replace on that URL pretty easily. So that was capturing traffic from an existing web test. You can also capture new sessions. So here you don't have to use what you've already made. You can go crazy and do your own thing. To do this, we'll just click one of the browsers here. It will pop up that browser for us. I'm going to try to share my screen or move this around a bit. And here we could see that in the background, it's going to show us there's already one request that's been captured. And now whatever we do in that browser should be captured as well. So if we jump over to the Test Studio web page, you can see it's jumped up to 60 requests captured now. Maybe we'll go into Discover More here. We'll go look at the Visual Studio plugin. We're up to over 100 requests that have been captured now. We can drill down in and look at all these different areas, and maybe we'll click into another page here. We'll do a comparison table. We're up to 137, 136 now. And maybe we'll go to the checkout here and look at some pricing. We'll browse some products, and we're up into the 270 range now, 272. and so forth. Okay. Whenever we're done with that, we can close the browser, we can click stop recording, and that traffic that we just captured will come back for us. So 287 requests. That last test that we did was 14. So quite a bit more that was captured from this particular test. And we really didn't go that far into the web page. But you will see that in this case, there are a lot of dynamic targets, a ton, right? Now, not all of these are valid. Not all of them are necessary. Some of these are just noise that we don't need to use in our load test. Again, the rule of thumb is to just turn them on, because actually in this next step, I'll show you how we can eliminate those. You can always turn them off from here too. And sometimes they're not well labeled, so you might actually have to talk to the development team to understand which of these are important and which are not, and so forth. All right, so that's the dynamic targets in this case. Now, as I mentioned, there may be some extra noise in this. So here's telerik.com/teststudio, and there's another Telerik there, and then there's CloudFront, Optimizely, and Google Tag Manager, and Demand Base, and all this other stuff. Now, typically, we don't want to exercise somebody else's traffic. Here's an ad from Twitter, it looks like. We don't necessarily want to exercise Twitter or Eloqua or Facebook in this test. Those happen to be there because they're integrated to our website. So if you're on our website and you see something cool and you want to share it to Facebook, you click a little Facebook button and it does the magic for you. Well, there's dynamic targets associated with that, and there are steps of that traffic that are associated with that, as you can see, this connect step. And really, we don't necessarily need this, and this is where this filter really helps. And we can delete things kind of line by line down here if you want to, but here you can do this at a domain level. So we'll just uncheck the ones that we don't need, and it will in turn unselect any of those below that correspond to it. So we'll turn off our Twitter and our, oops, let me get this back up to where we want it. We'll stretch this out a little bit. There we go. And there's some Bing and some CloudFront, Google, looks like Facebook, LinkedIn, all the social sharing kind of icons, if you can picture, that you might have. You might even see some YouTube in here as well. So I'm going to leave behind only that Telerik.com traffic that I was looking to exercise, actually. Oh, we'll leave the progress stuff as well. Up there's a Telerik there. We'll keep that one, I guess, and that one there. So now I've disabled all of those, and in turn it has unchecked any of the corresponding steps, which also will now disable or really just not use the corresponding dynamic targets. Okay, so even though we have all these checked on here, they're not going to be used if the steps are disabled, right? So some of those that might pertain to Facebook can live in that list. They can be set to dynamic, but since they're not even going to be exercised, then it won't be necessary. Okay. So we've filtered that traffic out. Again, you can go through and really delete things out that you don't want, or turn them on and off kind of at the step level here too. So that's capturing traffic from a new session. So we've captured traffic from existing web test. We've captured traffic from a new web session as well. You can use the different browsers if you'd like. And then also we can capture traffic from any local source. And this is really good for capturing API traffic. And then we can capture traffic also from any mobile source. And of course, that's good for capturing traffic from a mobile device. Now, if you think about something like Amazon, again, as the example I used earlier, there's probably a ton of people these days that are using that on their mobile device. So we have to factor that into our load test. We may want to simulate a certain amount of traffic from a desktop browser, but we also may want to capture traffic that's generated directly from a mobile app. There is some proxy settings that go along with this, and as you can see throughout our screens, you might see these blue links. That'll take you right into our documentation on how to set that up, so that you can capture that traffic from the device itself. Now, the device is not needed for execution of the load test, just the capturing of the traffic. Once it's captured, we'll just exercise that headlessly from within Test Studio. Okay, so there's 4 different options of capturing traffic right here. And a 5th option here that's letting us import user profiles or user scenarios from Fiddler. So if you're familiar with Fiddler, if you're a user of Fiddler, or if you even haven't heard of Fiddler, check it out. It's a very popular tool for debugging and capturing web traffic. There's some greater filter capabilities, and you can actually see, rather than kind of cleaning the traffic up after the fact like we did in Test Studio, you can actively kind of monitor it and filter things out during the process as well. So a little bit different. It's definitely one that I think our developer classes or developer teams prefer over our built-in, but either one works fine. And of course, Fiddler is our own product. You're actually using part of Fiddler when you're using Test Studio. It's built in. But that's another means of capturing these scenarios. So here we have the different scenarios, and this is where we may have different workloads for each of those scenarios. So the workloads are the distribution of load for each of my scenarios. So if we were doing a test to simulate a 9 a.m. Monday morning, we may have a heavier amount of people that are just doing the login portion on that application, and a smaller amount of people that are using cascading combo boxes and things like that. So we can basically put the slider where we'd like to divvy up the percentage of total load, and that comes from our settings over here. So in this case, I only have it up to 30. You know, we'll push it up a little bit. We'll go up to 60 today. I keep this actually rather low for demo purposes because the GoToWebinar and things that we're doing on the web can be degraded when I'm running a load test, and that's to be expected, right? We're actually generating load, and we really, in many cases, want to find out where things do degrade and where things break. So I do keep this pretty simple from a demo standpoint, but this is where you would put your 10,000 or 100,000. We've got some customers that are in the hundreds of thousands of virtual users to use to do their load test. So you could certainly do that. Now, Test Studio includes 100 virtual users with each of our Ultimate licenses. So if your team buys 2 licenses, you'll have 200 to use, and they can easily be allocated. That's actually done up here. I have 6 Ultimate licenses, so I have 600 total, and I can allocate those between my different machines. So, and then this is not something that's necessary. It's only if you want to split your pool across different scheduling servers. So let me refer back to my image real quick. There's usually a central scheduling server that talks to many machines. So I'm not telling Test Studio to give this machine 200 and this one 100 and so forth. All I'm doing is saying, hey, here's 500 available to the scheduling server, and then during the load test, it will choose how to balance those across the agents for me. So all that's handled automatically. But all we're doing when we're looking at that split here is if we had more than one scheduling server. So if you can picture, maybe we have 2 of these big test labs, and maybe there's 500 virtual users on each of our test labs, but one day we want to have all 1,000 on one machine so that we can do a little bit bigger load. Well, then we can easily change that up. So again, the scheduling server in this case is the one here in the middle. Typically, you're going to have one of those that connects to many, but you may also have more than one scheduling server when you have multiple teams and multiple labs typically. And of course, to answer the question that usually comes up after that, all Test Studio licenses include the storage and scheduling server capabilities. So really, if we look at this diagram one more time, I've got 6 runtimes and 3 full licenses here. So I have 9 different machines that could be scheduling servers, that all have performance profiling built in, that all can execute web tests, execute functional tests, can execute load tests as well. And then of course the ones that build and maintain the tests are the full licenses. Okay, so that's kind of the difference between a runtime and a full license. But here all we're doing is we're saying, okay, I've got more than one scheduling server. How do I want to split up my total pool of virtual users across my different scheduling servers. So at the test level, this is where we're going to specify what load ultimately we want to achieve. We may start at 59 and go to 60. We may start at 0, go to 60. It just depends on what you want to do. You're not required to build like this, but I do like to see how things kind of progress during sort of that growth phase, and then I sort of have a plateau here, and that actually comes from our ramp. So we could actually start right in with no ramp at all, or we could do more of your classical load test, stress test here, where it's going to continuously ramp. But I like to have a little bit of a ramp and then plateau, so I can see kind of during that growth phase how things transpire, and then sort of that maintained plateau phase, how things continue to work. I have this set just to run for 3 minutes, but you can set that to whatever. And actually, before I go further, let me jump back real quick to our documentation, because there's one more option I want to give you, or one more link here I want to provide you, which is called load strategies. And this talks about the different kind of approaches to load testing. Stress testing is sort of that general kind of 1 to 10,000 pedal to the metal. We're just going to add virtual users constantly throughout that test. And then as we scroll down, you'll see some of the data stuff there. And then here's more of the soak test, the endurance type test. This actually talks about running this test for multiple hours, days, or even weeks. And you really want to know, how does that application perform under strain for a long period of time, right? So it's a little bit more of a flat line and a constant level load typically in those scenarios. Okay. This gets into a little bit more on geographic diversity testing. This is actually where you might want to have run times in different countries, so you can actually distribute your load from different machines that maybe represent different areas of the globe. So there's lots of cool things you can do there as well. All right, so we've got scenarios, we've got workload distribution, and again, for the purposes of this test, I'm not going to hit public sites. I'm going to hit my own test site because I don't want to kill our GoToWebinar. So we're going to hit 100% of that 60 concurrent users going through the login process that's being data driven, if you'll remember. There is also the ability to manage Windows authentication identities, and so you can add the identity, and that's actually, instead of having a data-driven load test where each user uses a different set of credentials, this is really kind of the opposite. This is saying I want to provide one common set of credentials for all users, all virtual users that are going to go through the process. And this is something that's very useful when you're in a Windows authentication environment. We really just want to get past the authentication point so we can test the application itself. But you can create those identities, and then here you would actually select the identity to use for the scenario. Now on the bottom here, so we talked about sort of the strategy stuff over here. The only other thing we have left is this, and this is something we've already covered: monitoring performance. The same thing we saw before, now it's here in this environment too. So again, same thing. If we just click into this, we'll see the Windows performance counters. We'll see all of the data points that we can look at and evaluate and include in our test results and our load test results here. Oops, I do need to click on it, I suppose. And you can see I've previously set this up. This also carries over the same templates. So whatever you've done in performance testing, you should see here as well, and you can use those same templates. Now there's one other aspect of these performance counters that is different in load testing than in performance testing. We'll see that here in a moment. But now my load test is all kind of set. It's ready to go. My scenarios, my workload, my performance monitoring. And again, keep in mind that we may be monitoring machines that are not executing, right? We're just monitoring them. We just want to see how they're handling, especially in a load test. When you have your app server, you want to know, well, okay, I want to understand the user perspective. That's the execution agent. But I really also want to know, how is the app server handling things, right? Because the user perspective is a small segment of the overall load test. We're going to be generating multiple virtual users per machine, but it's the ultimate app server that usually tells us how it's doing, how it's handling things. If that goes down, then nobody has access to the application, right? The user experience is nil. But let's flip over here to the Run tab. And here on the Run tab with the load test, this is really, I think, a big differentiator for Test Studio. So because here you can actually give it the criteria to make a successful load test. And in order to pass a load test, you have to pass all of your goals. Now these goals, usually with a load test, people just think about one thing. They think about how many users can we handle, right? I call that the big boss number. The big boss says we got to be able to handle 10,000 users simultaneously. And that's a keyword too, simultaneously or concurrent. Usually people get a little confused about that. There's total visits and then there's concurrent visits, right? If we look at our Google statistics, we could probably get down to a minute maybe. I'm trying to remember how specific it does get, but we don't necessarily see at a specific point in time how many total users there are. I think we can usually get down to what it looks like for a particular hour and then sort of assimilate from there what type of load to use. But typically, again, that big boss number is, we need to be able to handle X number of users simultaneously, right? Now that's not the whole story, and that is in here. That's current virtual users for overall test. So we want to try to hit. We put this up to 60, so I'm going to hit 59. We're going to pass this goal if this goes over 59. And if it's a critical goal, we could say stop the test if this goal is met. Something like an errors per second, we may want to say stop the test if this goal is met, especially if we're about to run a 6-hour soak test and it starts erroring in the first 5 minutes. We might want to stop and look at that before we have it run for another 5 hours and 55 minutes. So you could certainly turn that on. But really the rest of these goals spell out what I call the edge of the cliff, right? Because current virtual users, how many users can we get on a website is great. It's a great concept of, okay, we need 10,000 users, but I've seen failures like that in the past. And usually what happens is people think about that big boss number, they're focused on that big boss number, and they're not necessarily thinking about the user experience. So what I mean by that is we may be able to fit 10,000 users on this website without the app server smoking and going down, but it may be a 15-second response time. We may have a fraction of those users seeing errors. So they're on our website, but they're seeing a 404 or something like that. So it's not just about how many users we can jam on there. It's about what's the average response time that those users are seeing. And of course, everybody likes to get to that sub 3-second response time. So we have a goal for that. And of course, errors per second. So I want to stay at 0 errors per second. Responses received per second. We'll maybe jack this up to like 25. We'll see if we can get up to that point. And then here's our big boss number and the goal for that. And I've also added another one, and you can actually add custom goals. The custom goals let you spell it out specifically what you want for your test to be considered a pass or fail. So we're going to create our own goal. We're going to pass this goal or fail this goal if either the overall test, which means all the machines involved, the execution agents, the servers that we're monitoring, all that stuff, if the overall test or a specific machine involved, and when we turn one of these on, now we've got all those performance counters that we've enabled. So we can actually go build very specific goals around these performance counters. We could do like a processor privilege time must stay under a certain threshold, for example, or transactions per second needs to reach a certain level. Now this might not make a ton of sense when you first see it. You might not know what your goals are to begin with, but the first key is to turn on the monitoring, because when these are turned on, we're going to get data back for every single one of these after we run the test the first time. And once we get that data back, then we can know maybe what values to start working on. So adding goals to your load test is something that you're going to kind of hone in on over time. Okay, so we don't expect you to know that right away or be ready to do that first thing. It's typically something that you'll want to sort of hone in on. But that really allows you to spell out what combination of things and values for those is going to equal success for your load test. So I have to pass all these goals in order to make a passing load test. All right, now if my agents are ready, I'll hit run this test, and it should get things started for us. It should talk to the scheduler. It should flip us over here to the Analyze tab here in a moment and start bringing some data back for us momentarily. So here goes the Analyze tab. There are a couple of notes up there you can enable. And you can see there's some previous results in here too. And as soon as we start getting new data back, it'll start giving us the new results. Now you don't have to be here for a load test. It is something that's kind of fun to watch and kind of graph things, but you can always schedule these to run as well. I always mention, don't forget you scheduled it to run. Oops, I had something. Oh, there it goes. Now it's starting. It's just getting started up there. So you can see it is running. I have it 3 minutes for 60 users. Here's some current values. And I have a sampling rate. I didn't point this out, but I have a sampling rate of every 5 seconds. So we're going to get data back every 5 seconds. Here currently are the goals that we're passing and failing. And here are page-specific metrics and any errors that may have been encountered and their status codes and so forth. Now, the real fun part of this, I think, is the graphing, where we can see as it's carrying out the test how many errors per second, how many requests received, how many sent, responses received, all those different values. And this is for overall test. So we do have all of the specific machine counters here too. So we can graph and map those and watch those as well. So just a ton, I've got a ton of these turned on right now, more than I probably need, but we could graph those, we can watch those, and we can see, and you see here it's coming back every 5 seconds with data points for us. Now what you'll be looking for, we have average response time that's staying relatively low. What you want to avoid is an average response time that's super low, because sometimes we may have a site that's failing and it's responding really quickly saying, hey, it's failed, right? So really, really low response time is an indicator that there may be an issue, especially when it's coupled with a spike in errors per second, which is 0 down here right now. The other thing we want to avoid, of course, is a high average response time. So typically when you see a server crash happening, you'll see the average response time spike, and then right after that average response time spikes, it drops drastically low, and at the same time, the errors per second starts to climb and climb and climb. So this particular graph looks like everything's pretty clean. The responses request and receive have been pretty much neck and neck the whole time. So that's very clean, looks like. And again, we can drill down into these different machines. Here we can filter down to a particular machine. And we may look at memory or these other ones that we've got here. Oh, there we go, some write per second. So you can see that spike occurring for the memory. Just a couple of those spikes. Now, sometimes you'll see spikes. They're not always bad. You might see more of a heartbeat where it's kind of flat and then spike and then flat and then spike. That's typical. When you see that type of pattern, that's typically okay. It's really where we look for those anomalies. And this one's suspect, but it didn't seem to cause any errors, so we're okay. But it was in that kind of growth phase. And as you can see, there's the plateau phase of my test. Now I think it's done. Yep, our test failed. We had 4 goals out of 5 passed. So let's look at our goals. We got the big boss number. We made it to 60 concurrent users. We had zero errors per second, so we didn't crash the server. Our average response time was very low, but not too low. And then a response received, we got where we wanted on that. And then this goal was really unaffected. Actually, I don't even have this machine, I don't think, on right now. So it's not grabbing any data for us. But that's our load testing result data. One more thing, I know we're running short on time here, but one more thing I'm going to show you is how we could take this data. So I have average response time errors per second, and current virtual users. I'm sorry, I have that set to overall test. So these three, and I'm going to jump back and look at, let's say the one in the middle of December here, we actually failed on our average response time and our responses received in that case. But what I can do is I could take that and map it over this current result too. So now I actually have two result sets overlaid on top of each other. Now both of these ran for 3 minutes. This one says 3 minutes and 9 seconds, and the reason for that, if there are virtual users still in the middle of doing something, they'll finish out. So in my load test, if I have a 5-minute long scenario and I run a 3-minute load test, well, guess what? That's going to last at least 5 minutes before the load test ends, because it will make sure that each of those virtual users finish their job before they're released. Okay, so it's natural to see it go over a little bit. But here you can see that spike in average response time. Looks like it didn't have any errors, but it was potentially close to erroring. And this was actually done at a lower level. This was at 30 users, so twice the number of users, and we still had very good performance. In fact, this spike looks to be somewhat of an anomaly, but this is what I'm going to continue to watch as I continue to increase this up to 90, 120, or whatever values I want to set it to. I want to see at what threshold do we start to see things kind of come apart. And again, keep in mind there's the idea of how close to the edge of the cliff are we, and then there's the cliff. The cliff itself is how many virtual users can we handle concurrently, or current virtual users as it's noted here. That's the big boss number of can we handle X number of users. That's like an on-off switch. You either can or you can't for that particular goal. But it's the other ones, the other goals that tell you more about, is it something that users are going to stick around and use? If it's 10,000 users and the server's still up, but it's 15-second response time, you're not going to keep many users around too long, right? Right on. So it looks like we're right at the right past the hour. I'm going to stick around a little bit, answer any additional questions that may come up. Please feel free to hit the question panel or the chat log with anything you might have. I want to thank everybody for attending today, and hopefully this has been informative for you. Definitely check out Test Studio for your own self, and let us know if you need any assistance. I'll also point out before we go where you can access the user guide up here in the help menu. You can get to the user guide online. You can get to videos and forums, and here's our feedback portal where you can ask us for new features and vote for things to help us prioritize our roadmap, and even submit ticket. You do have access to our support team throughout your trial. This is a supported product, so we ask you to go ahead and trial our support with our application as well. All right, so that's it for me. Again, thanks for watching. One more thing I'll note, I did talk about the micro vantage point of the performance test. The load test, as you may gather, is a macro vantage point, and I will let you know that it's good to run them together. Run a load test, and while that load test is running, run performance tests. As I mentioned before, with performance testing, you want to see how performance tests work at different levels of load. So use your load test to generate the load, and then hit it with performance tests while you're doing that. All right, thanks everybody. Have a great day. Thanks for checking out Test Studio, and happy testing.